5 discusses linear inequalities in one variable. So before we were looking at linear equations, which use an equal sign, now we're going to look at linear inequalities, which use the inequality signs of less than, greater than, less than or equal to, greater than or equal to. So linear inequalities, like linear equations, as I said, except they use, instead of an equal sign, they use less than or greater than, less than or equal to, greater than or equal to. They can also have many more solutions, sometimes, and most of the time, infinitely many solutions. So for example, if I say x is less than or equal to 11, any x value that makes that true would be 11 or less, going all the way to negative infinity. If I have x is greater than 11, well, that doesn't include 11 itself, but it's every single number greater than 11 all the way to positive infinity. And we graph these solutions on a number line, or we can write them in interval notation. We're going to go over how to do both. So solving an inequality is the process of finding the set of numbers, so not just the one number, whereas was the case with equations, the set of numbers that make an inequality a true statement. Again, we call this set of numbers that satisfies our inequality the solution. In this case, the solution set because there tends to be more than one number. And we say that these numbers satisfy the inequality, meaning we make the inequality have a true value. So let's talk about interval notation. So square brackets are used to indicate that endpoints are solutions. These are used with less than or equals to or greater than or equal to because the endpoint is included in our solution. And sometimes that's represented with a solid dot. Parentheses represent endpoints that are not solutions. So that's going to be greater than or less than. And sometimes those endpoints are represented with a hollow dot on the number line. So if I were to say all numbers less than 0, that would be from negative infinity to 0. That would be x is less than 0. We could rewrite it as an equation. If I were to say all numbers greater than or equal to 4, that would be when x is greater than or equal to 4. And we would write that with a bracket because that endpoint is included because x could be equal to 4 in this case, whereas if I had x was less than 0, 0 is not included because x has to be less than 0. It's important to note that infinity and negative infinity always get parentheses. Those aren't actual endpoints. There's no actual infinite number. They just keep going on forever. So they always get parentheses. Set notation, which we covered briefly in chapter R, also called set builder notation, is used to define a set as well. So I have x. For example, x is an integer between negative 3 and 4. This is where the set of all numbers x such that, remember this vertical bar, is such that x is an integer between negative 3 and 4. So here's a brief summary comparison of all the interval types, be it an open interval, a closed interval, and intervals to infinity. You want to go ahead and pause and take a look at all these different types real quick. We're going to go over examples for the most of these. So here's a couple properties of inequalities. So if I have for any real number a squared is greater than or equal to 0 because any negative number squared becomes positive. If I have a is less than b and I add a constant to both sides, then a will still be less than b. If I have a is greater than b and I add the same constant to both sides, again, keeping all things equal, I still have an inequality. What's interesting here is the multiplication property of equality. So we would expect that if c is greater than 0, and I multiplied by an inequality by c, of course, it's still going to maintain the inequality. What is interesting is if c is less than 0. So in this case, when c is negative, what happens here, if you don't notice, is you flip the sign. So if a is greater than b and I multiply it by a negative number, then it becomes ac is less than bc. This is the main point. This is the one key thing I want you to remember about working with inequalities. When you multiply or divide by a negative number, you flip the sign. So less than becomes greater than or equal to becomes less than or equal to, and so on. So how do I solve linear equations using both addition and multiplication properties? Well, we treat them like an equation really until it comes to our solution set. So first we simplify our algebraic expression on each side. We use the addition property to collect all the variable terms on one side, all the constant terms on the other. We isolate the variable and solve, and we flip the inequality if we multiply or divide by a negative number. Next, what you need to do is express your solution set in integral notation and graph that solution set on a number line. So let's work through a few examples.